Good morning, everyone, or good evening, depending on where you're attending from. And welcome to today's training session. Today's training session is going to be all about material fundamentals, essentially understanding the material workflow and how we can use it effectively with Falcon to add specific materials, to make use of textures, to create custom materials, and essentially understand how the material editor and how materials in Unreal Engine work in general. So, if you are from a CG background, you might have some sort of an idea as to how materials work. Maybe you work with materials in DCC software, right? So, the goal is to understand how you can integrate those materials with Unreal or rather create those materials from scratch inside Unreal and then effectively apply those materials to some certain use cases, which we'll be looking at with respect to Falcon. So before we do get started, I'd like to mention if at any point in time anyone has any questions or doubts, please feel free to unmute yourself or put them in the chat. We'll be more than happy to address them. We're also going to be covering a little bit of theory before we do get started. So I have a presentation which is going to give you all a brief introduction on what materials are and the approach that we're going to be using today within Unreal. And then once we're done with that, we'll go hands-on in the engine. Right? I'm going to share my screen. Just give me a second. There we go. Perfect. All right. So introduction to materials. Or creating realistic materials with respect to Falcon. That's what we are looking at today. The contents of our lesson are what is a material, physically based rendering PBR, what does that mean, texture versus materials, and generated versus image based materials. Our goals are to understand, of course, what materials are, learn how to use the material editor, create a material from scratch. So we're going to be looking at the material editor within Unreal, understanding how we can create a material. And then also, not only are we going to be creating a basic material using constants and vectors, but we're also going to be looking at creating materials that can leverage textures. Okay, before we get started, let's understand what a material is. Now, if you were to ask anyone with a CG background as to what a material is, they'll probably give you this boring, long drawn textbook definition that says a material is a collection of pixel data and or computation instructions that define a shader that is used on a polygonal surface object. You're tired by the time you're halfway through that definition, right? So let's understand what a material is in simple terms. Basically, a material defines how something looks. So anything in the real world which is tangible can be defined by how it looks, and that constitutes as its material. So if I were to ask you, like, okay, this is my mouse, can you define what it looks like? You might say, okay, my mouse is white in color. My mouse has some lights on it. It emits some sort of light. Uh, it's non-metallic, so it's got a smooth finish, but it's not reflecting light, so to speak. So it might be a little matte in nature, or it might be a little rough. Similarly, if I ask you to define the way this tree looks to me, you might tell me, okay, it's got a greenish brown tint to it. It's definitely not reflecting as much sun, so it is it has a rough finish. It's non-metallic and it has these grooves and ridges to it, so it's not smooth for sure. Now, all of these properties of the mouse or of the tree that we defined can also be used to define the material of said objects. So for example, if I wanted to recreate this tree within Unreal Engine, I'd create a material. uh, Firstly, to give it its color, I'm going to plug in a value into the base color node. Then I'm going to want to mention that the tree is non-metallic, which is where I'll plug in a value of 0 in the metallic node. And then it's also rough, where I'll want to give the roughness a value of 1. And then to add these irregularities to its surface, to add these grooves and ridges, I might make use of a texture, which is going to define the normal map of the tree. So Essentially, anything in the real world that is tangible can be defined by the way it looks, and that's what constitutes as its material. Now, before we talk about what materials, the setup that we use in today's day for materials, let's understand what we used in the olden days. I wouldn't say I would call it olden, but prior to our modern day workflows. Right? We made use of primarily four properties to define a material. So we had diffuse, specular, opacity, and normal, some of which we still use in today's material setups. But the problem with your olden day material setups was any material that was created for a certain environment or for a certain scene. In this instance, we have this zombie game where you have zombies running towards a character. Let's take, for example, this warehouse that we see here. The reddish brown material that we see that's representing the warehouse would have been created specifically for this use case. And this material, one of the biggest disadvantages of your olden day workflow, which was non PBR, was that your materials were not physically accurate or not physically correct. Now, what I mean by that is, if your lighting scenario were to change, if your environmental scenarios were to change, if you were to add fog, maybe you add some smog, maybe you change the lighting from a sunset to a sunrise, this material would not reflect those changes or would not represent what it's supposed to look like with those changes in effect. So what we use today is something called physically based rendering, which is essentially the calculation of what light actually does, as opposed to what we think it might be doing based on intuition. So there's some properties that we follow while following physically based rendering. Right? We need to make sure that, one, of course, the material is accurate. So if I'm recreating the tree bark that I showed you all earlier, we want to make sure that the material is as accurate in the CG world as it is in the real world. That might, that might mean that your colors should match. That might mean that your roughness coefficient should match. That might mean that your texture should match to some extent. Now, of course, physically based rendering is is based on intuition to some extent, right? Color matching can be done. You can never get an exact value for metallic, or you can never get an exact value for roughness. So you can never precisely match that, but trying to be as accurate or as photorealistic to the real world object in the CG world is important. And most importantly, it's important to be physically correct. Now, what that means is, you don't have to follow the laws of physics, but rather what it means is, if in the CG world or if in the real world, the look of your object is changing with different light conditions or under certain temperatures, then you want to make sure that the same thing is being followed in the CG world. So let's say, for example, I create a material for my mouse. I don't know if you can see it, but if I create a material for my mouse and I set it up in a CG environment in Unreal on an office desk, if I turn the lights down, the mouse should look how it does in the real world when I turn the lights down in the CG world as well. So this is based on intuition. There's no right or wrong here, but you're trying to be as accurate as you can. And due to this, there's some basic properties that we follow while defining materials in the CG world. So today, using physically based rendering, we define materials by true to real world properties. So the five most important ones out here are base color. Right? Base color lets you define the very basic surface color of a material. Metallic lets you define whether a material is going to be metallic or non-metallic. You have roughness, which lets you define how rough or smooth a material is going to be. You have opacity, which lets you define whether a material is going to be opaque or translucent. And then you have emissive, which lets you decide whether a material is going to emit any light from within itself or not. With the introduction of UE5, you do have the ability to make emissive materials indirect light sources in your level. So in your worlds, in your experiences, you can have 3D actors emitting light, which will also then light up a scene. So that is a feature of UE5, which is why emissive materials also play an important part. And then we have normal, which lets you define the surface of the material. If your material has any irregularities, like we saw on the tree trunk, if it has any grooves, any ridges, you can define that using a normal value. So base color is what we spoke about. It defines your overall color of your material. We do use RGB values in Unreal. So if you're used to hex codes, you might need to familiarize yourself with RGB values. We have metallic. This controls how metal-like a surface looks. Now, keep in mind, when we are defining material properties in the CG world, we want them to be as true to the real world as possible. So a metal is an object is either metallic or non-metallic. Right. Yeah. Thank you, Rebecca. She's shared the chart with us, which can help us refer to real world, which helps us compare the real world to the CG world. But as I was saying, an object can either be metallic or non-metallic in the real world. So it either has metallic properties or it doesn't. While in the engine, you can define something to be not metallic or non-metallic. So what I mean is you could give it a value of 0.5, which lies in between 0 and 1. Realistically, you wouldn't achieve that. And then you have roughness. This defines how rough or smooth your material is. Again, a value of 0 is going to be a perfectly smooth surface. While you can do it in Unreal, it's not recommended because in the real world, you can't have a surface that is 100% smooth and that has a 0 roughness coefficient. Right. Any questions or doubts still here? If there are any, please feel free to put them in the chat. And with that being covered, we now come to textures. Now, think of textures as image files that are used to create materials. So there's two ways you can define a material. One is if I give it numeric values. So maybe under roughness, I just directly put in a value of 0 or 0.1 or 0.2, which means that my material is fairly smooth. Or maybe I put in a metallic value of 1, which means that my material is metallic. That's one way to do it. Another way to do it is to make use of textures. Now, textures can be random images off of the internet. So no one's stopping you from creating a material and going off of Google and, just downloading something like this checkered pattern and plugging it into your base color and having a random normal map or a random roughness map and just plugging them in there. While you can do it, it might not give you the appropriate output that you want. So you can create it, but again, it might not make sense. So if you are using textures, you need to make sure that you're using baked maps, or you need to combine them into something called channel packing, which basically makes sure that you're using appropriate textures for an appropriate mesh. So think of a texture as gift wrapping paper, and then you're essentially wrapping it around your object. So in this instance, we have this audio recorder of sorts, and we have 4 different texture maps that are defining 4 different properties. You can see this is what the texture map for base color looks like. This is what the normal texture looks like. This is roughness, and this is metallic. Now, just looking at a texture, you're not going to be able to decipher what this mesh looks like. But only if you place these textures correctly will you get this output on only this mesh. So these textures are created specifically for this mesh. But what we can understand by looking at these textures is, if you look at the base color, you can see that there's different colors in here. There's off-whites, there's a dark gray, there's a light gray, there's some navy greens. If you look at metallic, you can see the whites and the darks, right? Which is basically defining which areas are shiny, which areas are not shiny. If you look at the normal, you can see which areas have grooves, which areas have ridges. So only when these four come together and are put together correctly, will you see it look correct. And it's only going to look correct on this mesh. If you were to place it on a random cube, it's not going to make any sense at all. So that's how you can use the correct textures and package them in the correct way to look right on an appropriate mesh. Yeah, here are some of the common formats that we use in UE5. Uh, Most commonly, we use JPEG, PNG, Targa. You do have a bunch of different formats which do work, but these are your most common ones that you will see us use anytime you import a texture into Unreal. And then we come to the material editor. This is what your material editor looks like. It might look complicated, but trust me, it's extremely simple to understand and use. You have primarily five different tabs right here. So you have a toolbar, you've got the viewport panel, you have the details panel, you have the graph panel, and you have the palette panel. We will be we will be understanding this user interface more on hands when we hop into the engine. But this is what your material editor looks like. Yeah, as Rebecca mentioned, you might also need to sign up on Falcon if you are following along. So do keep in mind you need a Falcon account. And then this is what your execution flow for a material looks like. You have one result node, which lets you define all these properties that we've been talking about. So base color, metallic, specular, roughness, world position offset, normal, emissive color. All of these can be defined either by numeric values like so, or by texture maps. But any node that you use in the material editor will have this execution pin on it. And this lets you connect to the result node using wires. You can see these noodle like squiggly wires. These let you connect your different nodes to each other. All right. And with that, we can now hop into Falcon. Uh, I've opened up Falcon Editor and I have a default project open. It's just a blank template. There's not much in here. So in case anyone is following along, what you want to do is you want to launch the Falcon editor. I'll show you all the steps. You simply want to open up this, you want to open up Falcon. And then under the Falcon tab right here, you'll see the template project.
Yeah, and make
While,
sure, oh, sorry, when you open it, make sure the starter content
yeah.
checkbox is checked as well.
So while creating a Falcon template project, just make sure you've included starter content because this is fairly useful for us when we are getting started. And then you can name it whatever you'd like. So give it whatever name you want. I already have my project open. Once you're done, you can hit the create button right here.
Yeah,
Yeah,
thank you.
the project might take a couple minutes to load. It compiles some shaders and whatnot for the first time. So yeah, while your project is opening, I'll quickly talk about some, and I can always revisit this step, but I'll quickly show you all what we're trying to achieve. So under the Falcon catalog, basically I'm just creating, I'm opening up a new project with the Falcon SUV within it, essentially giving us something, somewhat of a base to work off of so we can define materials. Uh, you need to quickly sign in again. Okay, and then just open up this map. Perfect. And then I'm also just going to drag out uh, this twin that we have here, which is the car. We could get rid of this one. Just going to leave it there for now, not bothering anyone. But this is the twin that we've got. Now, materials, the way they work is essentially, and again, once you do open this, you might not have access to your starter content, which is okay. But let's look at how we can create our first material and apply it onto a surface or apply it maybe onto the car or any random object. We could just bring in something like a cube or a sphere and apply it onto that. But essentially, if you do right click in your empty in an empty space here in your content browser, for some of you this might be collapsed like so. So you'll find it down here. I usually like to dock it so it's always open. I'm going to right click and I'm going to create a new material. Okay, and I'm going to call this, call it M underscore test material. All right. Now, this test material is what we're going to be using just to, play around with and understand how the material setup works. So once I open it up, this is the material editor that we looked at. In the screenshot, this palette tab was open and it was pinned, which is why you may have noticed it. Personally, I don't like this open because there is an easier way to access it, but you can choose to have this open or not from here. Okay, let's quickly understand this user interface. Up top, you have primarily two buttons that we are mainly concerned with, which is save and apply. That's the two most important buttons on the toolbar. Don't worry about stats, platform stats, preview state, clean graph. That's all more advanced and more technical. We don't need to concern ourselves with it. In the viewport, we can visualize what our material looks like. So currently it's undefined. So it's just this black material. We can use different shapes for to visualize our material on. So maybe you want to see what it looks like on a plane or on a sphere or on a cube. You have different shapes right here. Your details panel, very similar to your details panel within the editor, where depending on the type of actor that you select, it's going to show you relevant properties. Similarly, in here, depending on the node that you select or the function that you select, it's going to show you relevant properties here. If you do select the material output node or the result node, it's going to show you some fairly important properties. Again, there's a bunch of them. Don't worry about understanding all of them right now. But there are some important ones that we'll quickly discuss. So material domain lets you decide what type of a material it is. So a surface material is a type of material that you'll use to define a surface. Then you have light functions, you have post-process materials, you have volumes, user interfaces, all that sort of stuff. You also have different blend modes which let you define your material's behavior. So you could have an opaque material, which is most common. Then you may have a translucent material, which is if you're trying to create something transparent or see-through. You have alpha holdouts, alpha composites, again, more technical stuff. So nothing you need to worry about now. And then you have different shading models. So we're just going to use a default lit shading model, but then you can create a material that is unlit or a clear coat material, or you can create a material specifically for hair or for eyes or for cloth simulations. And you'll notice as I change the shading model, it also enables and disables a bunch of these different nodes for me, these result nodes. So we're going to stick to the default lit. And then you have the ability to make it two-sided as well, which means you can visualize your material from both sides. All right. Next up is a graph. This is where all the magic happens. This is where a material creation and ideation happens. Uh, any properties that you define, whether you're using a constant, whether you're using a vector, whether you're using textures, it's all going to happen here. So this is where you define the way your material looks and the different nodes that you can use to define your material, right? If you remember the presentation, there was a color box and then some of them were just numbers, some were textures. You can find them in your palette tab. So your palette lets you access these different nodes which help you define or perform some sort of operation on your result. So most importantly, you have constants. You have a constant 2 vector, constant 3 vector, constant 4 vector. You'll see a bunch of different nodes here which have these alphabets or numbers next to them. So the constants have 1, 2, 3, 4. Texture coordinate has a U. Material function has an F. And then you'll see a long list of these. Now, what these mean are these are shortcuts for these nodes. So these are your more commonly used nodes. So the engine has some shortcuts assigned to them by default. Don't worry about them right now. We will talk about them as we move on. And personally, I like to have this palette collapsed because you can find these same nodes if you right click in an empty space here. And out here, they are better defined or better categorized. So you'll see atmosphere related nodes here. You'll see depth related nodes. You'll see font related functions. You'll see hair color and then all your different math functions. And then your normal, your opacity. They're all nicely segmented if you right click. So let's create a simple material and let's use it to define. Let's create maybe a simple red material and let's define it. So maybe I don't like this blue car. I want to make it red. How do I do that? In my material, I can define base color in two ways. You remember there's either numeric values or there's a texture. We'll come to textures later. Let's look at how numeric values can define base color, metallic, roughness, so on. So I can right click and I can search for a constant. Now, a regular constant is the simplest block in your material editor. It's a building block. And if I drag out of this and plug it into base color, while I can put in any value in here, can put in an absurd value in here, it's not going to give me anything apart from 0, which is black, and 1, which is white. Having 100 doesn't make it whiter. So 1 is your white, 0 is your black. Okay. You might be wondering, how do I get a red or a purple or a green or a light green? For that, you can make use of a constant 2 or a constant 3 vector. So a constant 2 vector will give you two output nodes. And not only is this used as a mathematical or geometrical calculation as x and y, but it also is R and G, which is your red and your green. So if I were to plug this into base color, and keep in mind, your result node, each of these outputs can only have a single input. So base color can have just one input, metallic can have just one input, but your individual nodes can have multiple outputs, as you're seeing on my screen right now. So one constant can define all these properties if you like. But your result node, each of these properties can only have a single input. If you want to break a link, you can simply right click and you can break this link. Or you can hold Alt and left click and it automatically breaks the squiggly wire. So we looked at a constant which gives us just the ability to go 1 or 0 or maybe 0.5, right, at most. Gives us somewhat of a mix. But I want more color in my life. So I'm going to break this link. I'm going to plug in a constant 2, which then lets me do 1 for red or 1 in Y for green. And then if I mix both, I'm going to get yellow. And then if I do some clever combination, I can get certain colors. But again, it's too complicated. I'm not going to sit and calculate percentages for red and green to get my output. So why don't I make use of a constant 3 vector? So I right click and I search for a constant again. And now I have a constant 3 vector. And the constant 3 vector gives me access to, let's break this link and connect the constant 3 to base color. And now if I double click on this tiny black box, I have access to a color picker wheel, which simply lets me pick whatever color I like. Maybe I want a light pink. And it's that simple. Plug it into my base color and I now have a light pink material, light pink constant defining my base color. You also do have a constant 4 vector, which is a little more technical, which is the same as a constant 3 vector, except you do have access to an alpha channel in here. So if you're more in depth with materials, you can make use of your alpha channel to add or subtract from your material. Again, something that we won't be diving into today. So I'm happy with my constant 3 vector. I've created this nice pink looking material and I want to change my car to this pink color. How do I do it? Now, there's a few different ways you can apply a material to an actor. And you might hear me use the word actor quite often, but essentially an actor is anything that can be placed or spawned in your level. So this car is an actor. We've placed it in our level. Uh, And maybe I want to change the color of this car. How do I do it? So there's two primary ways to do it. One way is to simply drag and drop. So you see this floor with this tile texture on it. Can simply drag my material that I've created onto the floor and it changes the material. Okay, maybe I want the floor as it is. And the other way to do it is let's select my car. Now, this car out here is a twin. It's something exclusive to Falcon, which is actually a blueprint. So within my blueprint, without getting into the technicalities of a blueprint, in your details panel, you can find the mesh for your car right here. So first you want to select the car in your level. And then in your details panel, you want to select the car from here, SKM Falcon SUV. And if you scroll down, you'll see a materials tab. Now, this car is fairly advanced in the sense it has 12 different materials assigned to 12 different parts of the car. So you have two separate materials for the body. You have one material for the mirror, you have one for the window, you have one for the lights, one for the rims, one for the tires. So we're not concerned with the rims or the tires or the mirror, right? Although, you can modify these and play around with them. We simply want to change the color of the car. And we can see the materials in element index 1 and element index 2 are defining the body, MI car body. So I can simply take this new material that we've created and drag and drop it here. Or I can hit the drop down and I search for M underscore test material and I assign that. And we've now got a pink assigned to that. Can also do it for the headlights. I believe the headlight is element 3, which is metal frame color. Not headlights, sorry, your side mirrors. And now I've got completely pink car. Any questions or doubts? Are you all able to bring this car into your scene and create a simple material and define it so far? If you need me to repeat anything, please do let me know and I'll be more than happy to do so.
Yeah, can you just go over real fast again how to access this file?
Sure. So what I did was once I open up Falcon Editor and create a new project, I go up to File and then I go into Open Project. And under Open Project, you want to browse. And I'm browsing to this Falcon catalog, the link to which Rebecca has put in the chat. So you should be able to head over to that directory. And within Falcon catalog, you're going to see work. And what I want is the SUV Falcon. So I select SUV Falcon. We can select just the regular Unreal. And then you want to open up this SUV Falcon Unreal Engine project file. So you just select this and hit open. It might ask you to open a copy. You can just hit OK. And then it opens up this level with this default SUV in here. But what we've done is in our content browser, we've gone ahead and brought in this item to an example and placed it in our level. After which we've created the pink material that we want and we've applied the material onto this SUV. Right. Any questions or doubts?
No questions.
All right, perfect. Okay, now maybe I'm happy with the way this car looks, right? But I don't like the finish. This is too much of a matte finish. Maybe I want something more metallic, or maybe I want something completely matte. This is kind of in the middle of both. So I go back to my material, and now I know that, okay, I have the ability to change my metallic or roughness values using constants. So let's say I want a completely metallic shiny car, like you would a regular car, right? So maybe I define metallic. So I right click and I search for a constant If you do want to use the shortcut to create a constant, you can simply hold 1 on your keyboard and left click, and it creates the shortcut for you. Right? So maybe I plug in this constant into metallic and I say, okay, metallic 1. Again, I'm using a constant to define a value here. So I give this a metallic value of 1 and I look at it in my level. And again, keep in mind, if you want to visualize these changes, you have to hit the apply button or the save button. I prefer to hit save because it applies and saves the material simultaneously. So once I do that, I go back into my level and suddenly I notice that, okay, it is metallic, but it's not as metallic as I want it to be. It's not reflecting the sun directly off of it. This still looks a little matte. Now, this is because by default in Unreal Engine, although we've not defined roughness, your roughness coefficient is set to 0.5. So if you want it completely smooth, you're going to have to bring another constant. So you can again hold 1 on your keyboard and left click, and you have to plug this into roughness. Now keep in mind, in the real world, according to physically based rendering, we can never have a roughness coefficient of 0. So you might want to put in a 0.1 in here or a 0.2 to make it slightly realistic. But again, just to please your eyes, if you want a 0, sure, you can have it. And now we can visualize that, okay, this is perfectly reflective. And now it reflects everything as it would in the real world. Might look a little unrealistic at some point, if you ask me. But this is accurate to what we would, a chrome paint or a chrome wrap on a car in the real world. If I were to have roughness metallic at 1 or metallic at 0 and roughness at 0, you're going to get somewhat of a plastic finish, as you can see. So it does reflect light, but it also looks a little plasticky. Like so. And again, if you want to visualize it on something other than a car, you can always hit this tiny green box with the plus sign on it. That lets you quickly add something to the project. And you can head over into shapes and just bring out a cube right here. And then we know how to apply a material onto the cube. So we simply drag and drop this onto the cube. And we can also visualize this material on the cube now. Right? Uh, so we've got a pink material on the car. You can choose to have it metallic. You can choose its roughness values. You can assign all of that. And this is essentially how you define a material using numeric values. Again, keep in mind, there's a bunch of different nodes here. We're not going to dive into all of them. We will talk a little bit about world position offset because it's an interesting node that lets you achieve uh, some unique output. So we will talk about it a little later. But apart from that, a bunch of these, you can simply do a quick search and you'll understand what they mean. And without any further ado, let's look at how we can now define these materials using textures. So we looked at how we can use a constant or a vector to define these. Maybe now, instead of giving it a simple pink, I want to add some funky print to it, or I want to add a design to it of some sort. So what I'm going to do is quickly, I'm just going to head over and download a free image. So just head over to freepic.com, and honestly, we can download pretty much anything we want. So maybe something abstract. Yeah, maybe just abstract colors of some sort. This should be okay. Okay, this is a premium. You can select any image, doesn't have to be something specific. So this works. Okay, I'm just going to download this texture. And then we can head back into Unreal or into Falcon rather. And let's import this texture that we've just downloaded. So in my content browser, and again, it doesn't have to be the same image. It could be an image of yourself also, if you please. Any random image, just to understand how a texture can be used to define a material. So I'm going to hit import here. You see this tiny button in my content browser. Okay, and then I've saved it on my desktop. I'll quickly just rename it, call it T underscore sample texture. Again, keep in mind we define materials with M underscore as a prefix, textures are T underscore, and this is a good naming convention that you should follow. It helps streamlining a lot of the work that you do. So I'm going to import T underscore sample texture to my project. Once it's inside Unreal, this is what it looks like. It's very high quality texture. It's about 5.6K by 3.2K. And now maybe I want to use this texture to define this cube or to define the cast surface. So how do I do that? I come into my material. All this while I've been using numeric values to define my base color. So this time I want to use the texture. There's a few ways you can do this. One is you can drag this texture and drop it in here. And it'll automatically create this texture sample node for you. Or you can manually search for the texture sample node. The shortcut again is T on your keyboard and left click. And I really like this feature about Unreal where if I have a texture selected and I add a texture sample node, it automatically assigns it here. If the texture is not selected, you'll notice that it doesn't auto assign it. But then again, I can always go in here and then in my details panel, you'll see this nice slot there where I can assign the texture. So we saved it as T underscore sample texture and you can assign it right here. And then I take my RGB and plug it into base color. And I've got my texture now representing my base color. And now it looks like this. It gives the car a nice funky look. And this is what it looks like on the cube. Now, what you might notice is this regular straight pattern that it's following on the cube is not being followed across the car. So the car, the different parts of the car, so to speak, are geometrically, not aligned in the same way. So you'll notice that it's not following a regular flow. It's sort of wonky. But what we can do is we can also tile this texture if required. So maybe I want this pattern to repeat twice, or I want the pattern to repeat in a 2x2 matrix, like 4 times. How do I do that? Very simple. You'll notice that your texture sample has an input out here for UVs. Okay, UVs also translate to your X and your Y. So this is calculating your X-axis and your Y-axis for this texture. So what I can do is I can bring out another node. Shortcut is U and left click. But if you don't want to use the shortcut, you can simply right click and search for this node called texture coordinate. And this is the one you want. And then I plug in my texture coordinate node into UVs. And now it lets me tile this texture. So maybe, as I said, right, I want a 2x2 or a 2x1. I simply select my texture coordinate node. And in the details panel, you can see I can add tiling for U and for V, or for X and for Y. So maybe I make it a 2x2. Again, keep in mind, you're not going to visualize this. While you will see it update here, you won't see it update in your viewport. So you do need to hit save, or you need to hit apply. Save does both. And now we see it tiled in a 2x2. And, you might like this more than the previous version. Right? Or maybe I want a 3x1. So this is what I get. Right? And then similarly, instead of defining roughness by a constant, I can have a roughness map that helps me define the different areas of this vehicle, which might be smooth or which might be rough. Again, I don't have these textures for this vehicle, which is why I'm not using them. But nothing's stopping me from going online. So could just go to Google and type in roughness map, and I'm going to find a roughness map. You'll find thousands of roughness maps. Again, won't make sense because these are for specific meshes, but you will find something. And plugging it in, I'm just going to save this image. Just call it T_roughness car, roughness car. And you don't have to follow this step. I'm just trying to show you how these work, where if I now import this texture that I've just saved, okay, you'll see it's going to import it as a roughness map. And instead of having a numeric value define my roughness, I could bring in another texture sample with the roughness map and plug that into roughness. And you'll see that doesn't really make sense. While it does work, there's no real logic, or it's not adding to the texture. All right, it is giving it this cool, funky sort of watermark effect, but it doesn't necessarily make sense. Oh, the car textures are in the content file. Okay, great. So we do have the textures for the car. Interesting. But just to show you, right, you can use a roughness map, any random roughness map, but you might not, it might not make sense. We can see a bunch of the different car textures here. So we can see car body 1R, which stands for roughness. So this might be a better fit. And you can see if you make use of the correct texture, it also applies the correct property. So this is what it looks like when we use a roughness texture, as opposed to if we define roughness manually with a constant. So you do need the appropriate textures to define your appropriate values if you're using specific meshes. All right, any questions or doubts? So far, you should be able to create a simple material. You should understand how you can define the material either with constants and with vectors, as well as defining them with a texture. So there's two ways we've looked at how we can define a material. If you've understood this, you're doing great so far. And if you're able to integrate it into your level, it doesn't have to be on the SUV. It could just be a simple cube. We are using the SUV because we have it available, and we're then going to convert it to a twin. But if you're able to recreate this so far, then you're doing amazing. If not, if you have any questions, I'm sure you're still doing great, but do let me know and I'll be able to address them. We're going to look at once we are done with this, I'm going to show you all two sample materials which are related to world position offset. And the sole purpose of understanding these is we know that Falcon is primarily used for engineering simulations and very physics related. It has sensors, it has a bunch of calculations happening. So world position offset is an amazing node, and it lets us achieve certain output or lets you manipulate vertices of a mesh based on the position of that mesh in world space, or based on certain values given to that mesh. So we're going to look at world position offset and how it works. I have two sample materials created. I will restart the project and have it opened up. They're not here right now, but I do have those two examples ready. Before we hop into that, any questions or doubts? So before I do reopen the project, there's one more step that I'd like to do, which is when I'm happy with the way my car looks, maybe I'm going to remove the tiling. I like the way it looked as is. So I'm just going to do one and one tiling. And I like this look. So I'm going to stick to this. And my next step is to convert this blueprint of a car into a twin, which we can then use as a scenario. I'm going to right click on this item twin example. Now, typically I want to open this up and change the material within the blueprint itself. So I'm going to open up the blueprint. You can double click the SUV and then select the SKM Falcon SUV. And then in here, we want to just replace this with M underscore test material. These three values, which is element 1, element 2, and element 3. M underscore test material. That's the one we want. And we can compile and save. Can also close our material. And once we're happy with that, I'm going to right click on this item twin example. And you'll see an option under common to promote this to a twin. So if I promote this to a twin, it's going to be available for me to use in different Falcon scenarios. Let's promote this to a twin. And I'm going to call this, let's say, car underscore funky underscore twin, because it's got a funky color to it. I'm just going to call it car funky twin. Twin type can remain item twin. Don't need to change anything else. Just hit promote. And you should be good to go once it says twin was promoted. Right? With this done, again, you don't need to follow this next step that I'm doing. You can have your editor open. I'm just going to restart Falcon. And I'm going to open up my initial project that was open because I have two materials in there that I'd like to show you all. So we have the materials project. Open this up. Quickly sign in. You do need to sign in each time you open up Falcon. So I recommend setting a password that you can remember. Okay. There's two materials setups that I'd like to talk about. One is M underscore absolute world position. So this makes use of this absolute world position node. And then one is vertex normal, which relates to your world position offset. Okay. To visualize both, I'm going to bring in a simple sphere. Okay. Let's drag in a sphere. Let's place it here. No need to save the map. And let's understand this material absolute world position, what it's doing. So what's happening here is I have two constants, or two vectors rather, and one is red, one is blue. Now I'm interpolating both of these using a linear interpolate and plugging it into base color. So whatever my alpha value is, it's going to give me that percentage of a mix. So if alpha is 0, it's going to give me a pure red. Alpha is 1, it's going to give me a pure blue. Alpha is 0.5, it's going to mix red and blue and give me a 50-50 of both. But what I'm trying to do here is I'm trying to create a material which is going to change color based on the height of the object which it's attached to. So in this instance, maybe you're defining a material for a vehicle and you want it so that the further up your vehicle goes, maybe you're driving in the mountains, the different the car's material. So I'm making use of this absolute world position node. This is taking the absolute position or the world position, and then it's dividing that value by 1,000. Now you might wonder, an absolute world position has three output. You have XYZ, you have XY, and you have Z. In Unreal, we know that height or the up axis is the Z axis, and that's your Z. Now divide by 1,000. Why? Because each time we place something in a level, you'll notice that it has some sort of elevation, unless it's at 0, which is your origin. You will notice your Z value here. It has some sort of an offset from your origin. And because these tend to be larger numbers, we're dividing by 1,000. So if I have 500 divided by 1,000, that's going to be a 0.5. Or if I have 1,000 divided by 1,000, that's going to be 1. So I'm dividing by 1,000, and the output of that, I'm clamping to either 0 or 1. What that means is if I have 550 divided by 1,000, it's going to be 0.55, which is going to give me output 1. If I have 499 divided by 1,000, it's going to be 0.499, which is then going to clamp to 0. And then I'm letting this clamp value decide my alpha. So earlier, we defined what we want this blend to be. We want 50% red, 50% blue. This time I'm going to let the clamp output define my alpha. And now, if I assign this absolute world material onto the cube, onto the sphere, you're going to see the lower it is, right? The closer the value to 0, and that's my A. And then the further up I move, it's going to be more towards blue. You can also visualize this on a cube. Let's bring in a cube. Right? So this is one approach. I was going to save the map. This makes use of absolute world position. And then the second example that we're going to talk about is your vertex normal, which is plugged into world position offset, which is what we spoke about earlier. Now, this material, again, I'm going to apply it to both of these. Currently, you're not going to see much happening. Let me break down the material for you. Basically, you're giving it a base color. Doesn't matter. You can give it any color. And then I'm making use of a noise node. I can control the noise from here. Got a simple value of 1. I'm adding a 1 to it. I can choose what value I want to add here. I'm multiplying it by 0.5 and then remultiplying it by 1. So I'm basically adding irregularities to it. You can add as many adds and multiplies as you want here. It just lets you add irregularity to it. And then eventually I'm multiplying all of this with this vertex normal node out here. If you want information on any of these, you can always hover over them and you can hold Control and Alt. And you'll see what it says. The vertex normal expression outputs the world space vertex normal. It can be used in material inputs that are executed in the vertex shader, like world position offset. And this output, I'm going to plug into world position offset. Again, if you don't understand this, if you're completely new to materials, it's perfectly okay. But just try grasping the concept of what world position offset works, of how world position offset works. Now, if I were to change any of these values, maybe I change this multiplier to 8, or I change this multiplier to 2. I change the add to 2 maybe. You're going to see that it gives me this funky shape. on both my meshes. On the cube, it looks very weird. Right now, the point out here is when you make use of world position offset, while you may use it in Falcon effectively for a large variety of use cases, the point here and the important thing to remember is collisions while you're working with these meshes are not calculated from these vertex offsets. The collisions are calculated at the absolute position of this sphere or of this cube. The perfect example for this is grass or foliage, which we'll look at shortly. You do not, when you're playing a game, you don't walk on top of the grass, right? Essentially walk through the grass like you would in the real world. So that's one perfect use case of world position offset where you're adding irregularities to your surface in the form of grass, but your collision calculations are not done at the position of the grass, rather it's at the absolute position of the mesh, which in this instance is the sphere or the cube. And in the instance of a game, it might be the ground and you're just walking through the grass. So if you do get deep with materials and Falcon, this is something you might end up using quite often. So it's important to understand this concept.
Can I add real fast too? The reason why the cube looks so weird versus the circle or the sphere has a lot more points or vertices that can be altered, whereas the cube only has them, it's very simple as opposed to the sphere. So it has fewer vertices to alter. So it's a little bit like resolution. So you can think of it like the sphere has a higher resolution, and so the variations look better on it versus the cube is like very, very quote unquote low resolution. That's not the right word, but you can think of it like that. Whereas like the more points you have, the more some of these irregular roughness and stuff will look better.
Yeah. Thank you, Rebecca.
Thank you.
And if if you look closely, you can kind of see the sides, but you can tell that they are fully distorted. All right. And then before we hop into a scenario and bring in the car that we created and just visualize it, there's one last topic that I'd like to cover, which is material instances. Now, you will have noticed that each time we make a change here, right? Maybe I lower this to a 1, which is going to give us almost zero irregularities. You notice each time I change this value or I change the color, I've got to hit save or I've got to hit apply. And then it does this whole process, right? Applying changes, saving asset. Sometimes if your material is very advanced or it's a more technical material, if you hop into starter content and you go into the materials folder, maybe you open up something like water, you'll see that these are far more advanced materials. So if you were to make a change here, you'll see that the whole saving process takes some time. Saves, then it compiles shaders and it applies it. While you're on a fast system, you might not notice it, but point being, you cannot visualize these in real time. Any change that I have to make, I can't visualize it in real time. I have to come here and I have to hit apply or I have to hit save, and only then can I see this change. So material instances help us eliminate this completely. So what it does is any change that you make, you can visualize in real time. So not only does it save time, but also helps save computation. So how do I achieve that? Yeah, there will be time for questions, John. Don't worry. The way I can eliminate that is I can essentially click on any of these constants. So maybe the add or maybe this constant, I right click on it. And we just take one example for now. So maybe I right click, convert this to parameter. I'm going to call this base color. Okay, and what this lets me do is once I do that, I can right click on this material and you'll see an option to create a material instance. And now with this instance created, let's apply it to a cube and to a sphere. And let's open it up and it looks a little different. It looks like this. But you see it has the option to enable my base color global vector parameter. And now any changes that I make, I'm going to visualize in real time. So I don't need to do the whole save and then apply and all of that, right? Any changes that I make, it's all happening in real time. So that was the last concept. With that being covered, I quickly want to open up a scenario and let's look at the twin that we've created, and then we can hop into a Q&A. So I'm going to go on to File up here and let's open up a scenario. Now, to open a scenario, I'm going to go back to my Falcon catalog folder, which is, for me, it's in C, users, admin, Falcon catalog, and scenarios. Okay, you should be able to, once you're in the Falcon catalog, you should find the scenarios folder. Let's open this up. And then I'm just going to do the very first scenario. And I'm going to open up the USDA file. So I just select the tutorial FalconEditor 1.usda and open. And it'll take a minute to open up. But we are now hopping into Falcon mode as opposed to Unreal mode, which we were in all this while. And in here, in the Falcon folder, you'll see another twin subfolder. And within this, you will see all the twins that I've created. You remember we promoted the car that we created to a twin. So I'm going to open up car funky twin and you'll see a USD file. You can simply drag that and place it into our level. And we have the car. For some reason, it looks like the material wasn't saved to it or applied to it appropriately. So you can modify this blueprint here as well. While it's not recommended to change the materials right here, I think maybe I forgot to save, or maybe it didn't promote to a twin properly, or
Yeah,
there
you'd
could
have
have
to
been
go
something. Sorry,
back.
Rebecca,
You'd
you
have to
said?
go back into Unreal mode and promote it. If you change some of the parameters of a
Yeah.
twin in Falcon mode, it can cause some major functionality problems.
Exactly. So you do want to make sure that if you want to change the material, the twin is correct. We renamed it car funky twin. I might have another car twin in here somewhere maybe.
I
So
was
they're
gonna
all the same color. Yeah. I've not modified the material, but if you do want to change the material, you have to go back into Unreal mode where you go in here and then you open a project and then you open that instance. But essentially, uh, once the twin is in here, don't modify it in here or don't change the material in here, but you can then bring it into Falcon and then you should have your output here. Any changes that you make, you want to make sure you're promoting it to a twin again, or you're making sure your content is saved. And this is how you then bring it into Falcon, and you can now use all of your sensors and all your Falcon properties onto this
say.
vehicle.
I wonder if the vehicle in the viewport was just an instance of it, but not actually the mesh, because when it promotes the mesh. So maybe the blue was the mesh. So when you promoted it, that's what became the twin. Versus if you
Possibly.
wanted the funky one, I think you'd have to like say create a new mesh out of this one or go back and specifically edit the mesh. I can't remember if that was done or not.
Yeah, I may have forgotten that
Yeah.
step. So,
But
but
it's a good
essentially,
illustration of the difference between Unreal mode and Falcon mode. Falcon mode's where you like assemble and run the simulation, and then Unreal's where you do a lot of the editing. They look very similar, so it can get confusing. But as I said before, if you try editing in Falcon mode, it'll look like it's working. But if you save, close, open it again, run a simulation, some problems might appear. So recommended that
right.
you do not edit in Falcon mode.
And I think what I was doing was maybe I was editing in Falcon mode, I believe, which could have been the case, which is why the material didn't take effect. But yeah, you do want to make sure
Yeah.
you're in Unreal mode as opposed to Falcon mode when you're editing, and you shouldn't have any problems then. But that also does bring us to an end to our materials session. We can open it up for Q&As now. So we have some time for questions and answers. John, if you have any questions, please feel free to ask us and we'll try our best to answer them.
Yeah, awesome. I think it was really cool how you can apply different textures to different materials. I think especially in the research world, that's very helpful. I have some questions though. So
Sure.
I know in Falcon editor or Unreal, you can create simulations to capture large amounts of data. Can you dynamically change textures between when you're capturing this data? So for example, like I capture, let's just say, for example, the car, I want to capture a bunch of images of a car. And then between the data collection, can I change my material like dynamically, like the roughness or
Yeah,
the metallic?
you can. So one way to do it, so one example that I showed you was depending on height, right? Varying heights can have different materials. But then what you also can do is, you can program it to be something as simple as you hitting one on your keyboard and the material changing. So that definitely is possible, but then you're going to have to program it using blueprints. So
We
blueprints might, sorry, Rebecca, go ahead.
Yeah, so we actually do generally access the blueprint classes through Python. So what you'd have to do with the twin is you just have to create. So if you want to change, let's say the roughness and the maybe not world offset, but the normals, because the normals would create little bumps as well. You would just, when you're in Unreal mode, you would create like a parameter that can be controlled then by the Python script, so that when you're in simulation, you can use a Python script that would either like maybe every certain time step it would change. Maybe if you're capturing an image every tick, you can change that material every tick, but it's very controllable. You just have to make sure that there is access to it when you're creating the twin. And if you want to learn more about that, there is a tutorial in the exercises section of the documentation about a reflection system. And that I think talks about, I think that's one, or maybe it's creating a system twin, but that talks about how to create a parameter in your twin that then you can edit with the Python script as the simulation is running.
Okay, cool. Yeah. Thank you. So, and I'm assuming this also applies with, for example, if I wanted to apply a completely different type of texture,
Mm-hmm.
would I could apply different textures like throughout the shots, not just like randomly like creating like a not randomness within the texture as well.
Yeah, as
Did
long
that
as the
did that
parameter,
question make sense?
yeah,
I
as
was a
long
little,
as
you got it. Okay.
so I think what he means is, rather than just changing a value like metallic or roughness, maybe I want to change the texture. So I think
Yes,
to answer that, yeah, as long as your parameter is exposed when you create the
yes.
material, you should be able to control it. And then you
Okay,
can
cool.
program it. Yeah.
Okay.
Yeah. You just have to like specify what you want to be changing in the simulation while you're creating the twin. Because once you bring it into Falcon mode, as I said, you don't want to be editing it, but you can edit all of that in the Unreal mode and using the Python script in the simulation to then change those variables that you exposed.
Okay. Interesting. Awesome. My last question is, so obviously I'm assuming you can import like your own asset. So for my example, I'm working with a lot of images, so I would work in like a 2D space, if that makes sense. So could I like import essentially a bunch of images or like something like that, like on a 1D plane and just capture it like just with the camera facing down?
Yeah, so
You
you'd have
can.
an
Sorry if my question.
orthographic. Yeah, you'd have an
Yeah.
orthographic view of the asset. It would be like just a 2D flat plane, and then you could project the images onto it. And I'm thinking that you could also probably, so if you have like a base image that then you want to add variations on top, you could add maybe like roughness or normal variations on top of that using those different modes. So if like base color was the image, and then you could put in variations into those other nodes, like the roughness, the normal, even world offset. But as I said before, you need more of a denser mesh for that to be effective.
Yeah. So you'd basically
Okay.
import it as a texture like we looked at earlier. Again, you want to do this in Unreal mode and not in
Yeah.
Falcon mode. But you import it as a texture, and then you could, it can be something as simple as just bringing out a plane and then applying it onto the plane. And then maybe, I want to go into top view. So I view the plane just from the top view. Again, it has no texture on it, but I go into lit mode, and then this is what it looks like. Again, this is, given your lighting conditions are satisfied, like I can move my lighting. So something like that.
Yeah,
And
exactly.
given your
So
images applied on top. Yeah.
Yeah.
So I could essentially apply an image. Can I change only a section of the image though that I put on the plane?
You
Or
can,
does it
yeah, you can do that using the material editor.
okay. So if I have the annotations, let's just say for the image, and I want to apply it, I could just do that like in the background.
Yeah.
Yeah, I'd like to point out too, like the car had a lot of different materials, right? Like the bumper was a different than like the car door. So one of the ways you could do also is if there's like a section that has variability, but the rest of it stays the same. Those are just like two different, they're called like UVs. And so then you like change the one that's just for the one that you want to change, but the other one's separate. So you kind of can separate them out, but they're still on the same plane, but they have different materials on top of them. Does that make sense?
Right. Yeah. I think
Yeah.
I know what you mean. Yeah.
Like if you look at the car, it looks like one solid material right now, but we know that we could just change the color of the door if we wanted to because it's separate. So if I wanted to put like a decal on the door, I could change just that door material and it wouldn't decal the entire car. It would just decal that one.
Yeah, that's kind of what I was saying. Like just like
Yeah.
with part of the image, like yeah.
Yeah.
So you can okay.
Yeah.
Okay, cool. Awesome.
I'm glad this was helpful.
Yep. Thank you.
Perfect. All right. I think that brings us to an end to today's
Yeah.
session. Thank you all for your time. Thank you for attending. And I hope you all have a great day and a great weekend ahead.